um, simplify simplify the following expression to a single trigonometric ratio. So, okay, we know we are not supposed to use a calculator, right? So here's what they gave us: 1 minus sine of minus theta times cos of 90 degrees plus theta divided by cos of theta minus 360. So basically that's what we have now. Let's see. Sharp. So it's on the we'll try by all means to simplify each and every expression on its own, to not make things complicated for yourself. And they are offering you 5 marks for something like that. So, okay, let's see. It's going to be 1 minus, and now we have sine of negative theta. So, you're also going to need your Cartesian plane here, your cast diagram. So already we know all students take care. Then we know the ratios, right? So here I have 0, 90, 180, 270, and then 360 here. Sharp. So when we have now a negative angle, what you're going to do, since we are measuring our angles around the circle, which is basically giving us a revolution of 360 degrees. So what it means is that whether you add 360 degrees or you subtract it from an angle that you are given, it will remain the same, right? So to make these negative angles easier for you to understand, you're just going to add 360 degrees to that negative angle. Is that clear? To the negative angle. So I have 1 minus sine of, now since I'm adding 360, I will have 360 degrees minus theta, right? And then once I did this, now it looks familiar, right? And then I'm gonna have multiplied by the cos of 90 degrees plus theta. So what does that tell me? Okay, they say cos of 90 degrees plus theta. So in my cast diagram, I can see your 90 degrees here it is. And then, we measure our angles going anti-clockwise, right? So from basically 90 degrees, when I have to add whatever, an angle of whatever size, I'm going to end up in quadrant 2, right? I'm going to end up in quadrant 2. And I know that in quadrant 2 now, my cos is negative. My cos is negative. So, okay, I know that I'm in quadrant 2 and then my cos is negative. So what am I doing? Since it's multiplication, I'm going to have to put a bracket. And also remember, we won't just write, because now we are just trying to work it out, right? We won't just have a cos minus cos of theta, So what we are going to have when we are dealing with 90 degrees and 270 degrees, what we do now is that we use the opposites, right? We're just gonna use the opposite. So if I have now minus cos theta, I'm gonna switch it to my sine. So cos goes hand in hand with sine, right? So I'm just gonna have now minus sine of theta instead of minus cos of theta. All basically on our numerator side. Then going to our denominator, we have cos of theta minus 360 degrees, right? So that's a negative angle. But then also, as I said, whenever you are given a negative angle, what are you going to do? You're just going to add 360 degrees to that angle. Ne? So we are just going to have cos of theta minus 360 degrees plus 360 degrees. And obviously now, minus 360 plus 360 will give us a 0, right? And we'll end up with just cos of theta now. So now let me just write it down, then I'll do 2 steps. So I have cos of theta minus 360 degrees plus 360 degrees. Né? So okay, let's just deal with everything properly. So I have 1 minus, now sine of 360 degrees minus theta. So 360 degrees minus theta puts me in quadrant 4. And in quadrant 4, my sine is negative. So I will just have a minus sine theta, right? Then I'm multiplying it with another minus sine theta. Then I'm dividing everything with a cos of theta. So let's see. Now we're going to have 1 minus, we have now negative sine theta multiplied by negative sine theta. So that's just going to be a positive, what's this? Sine squared theta all over cos theta. Ne? So just to finish everything up, 1 minus sine theta, ne? Now it takes us to our trig identities. So 1 minus sine theta, we can now put it as cos squared theta. From the trig identity of cos squared theta plus sine squared theta equals to 1. Ne? So making cos squared theta our subject now, we are going to have it being equal to 1 minus sine squared theta. Can we see that movement? Ne?
Yeah.
Then we divide it by cos theta. Then as you can see, that one will cancel this one, and our final answer will just be cos of theta. Okay. So that was just basically how you will simplify the first one. That's how would you would go about that in a nutshell. So let me, that cos of 20 degrees is equals to P. So this is what we are given. Cos of 20 degrees is equals to P. Then they say, without using a calculator, write each of the following in terms of P. So, okay, when you have something like this, ne, what we are going to start with, first of all, is to draw ourselves a triangle, right? We are gonna try and draw ourselves a triangle. As I said, guys, please excuse the noise. Please excuse the noise, guys. Please excuse the noise. So, yeah, let's just try and draw ourselves a triangle. So we have cos of 20 degrees now being equals to P. So that means we can have a triangle in quadrant 1. Then here's our angle of 20 degrees, right? So if the cos of 20 degrees is equals to P, that's now my adjacent over a hypotenuse. So I'm going to have P here, and then I'm going to have 1, right? Because it's the same as cos 20 is equals to P over 1. Yeah? Then I'm just going to find my opposite side using Pythagoras quickly. So I'm just going to have my y squared is equals to my 1 squared minus P squared. Then I'm going to root everything, square root everything. Then my y now is just root of 1 minus P squared. So here's my root of 1 minus P squared. So now I have basically all of the sides in my triangle. Then I can use, I can basically answer everything without using a calculator. Now I can do that. So let's see. Okay, let's see. So 5.2.1, they say 5.2.1, they say cos of 200. So that's what they want us to look for. And then they are only offering 2 marks. Ne? So let's see. I have now 90 degrees here. Ne? So 90, what is a 90 minus 20 degrees? That's going to be 70, right? So that means I have an angle of 70 degrees here. Ne? So now I have basically all of my angles. So when they are looking for cos of 200, they're just going to try by all means to look at every possible angle that you can come up with. Cos is still negative. Ne? So it's 180 degrees plus theta because we are in quadrant 3. So 200 will be somewhere here. Ne? So sharp, another way of writing 200 will be what? 180 degrees plus 20 degrees. Then to reduce it, you'll just say minus cos of 20 degrees. All right. Then if we refer back to our triangle that we have here, we can find minus cos of 20. Ne? And then, yeah, it's just going to be now, we put a negative, and then cos of 20 is P. So we are going to just have a P. Then our final answer is minus P. Are we seeing that? Ne? 0.2.2. We have now a, what's this? Sine of negative 70. Ne? And they're also offering 2 marks. So we have a negative angle. And then what did I say about a negative angle? You see.
360.
We are going to add 360. So we are just going to have sine of minus 70 plus 360. Yeah? And that's just going to give us a sine of what? 290. Yeah? That's just going to give us sine of 290. Then you go to your cast diagram, you can see this is something that we can reduce, right? So we have 0, 90, 180, 270, 360. So 290 is in my fourth quadrant. Né? And in my fourth quadrant, sine is negative. So, and I know my reduction formula is 360 minus theta. 360 minus theta. Né? So I'll just have negative sine of what? 360 degrees minus so it's just going to be minus 70, right? That's gonna put me back to 290. Then it will just be minus sine of 70. Nah? So now I have a negative sine of 70. So first thing, I'm just gonna put the negative, then I'm gonna look for the sine of 70. And you see what I did back here. Let's go back to my first Cartesian plane. Né? Let's go back to my first Cartesian plane. I looked for every angle within my triangle. So now here's my 70. So if this is my 70, that means now referring from my angle of 70, this is my hypotenuse, this is my adjacent, and then this is my opposite, right? So if I'm looking for sine now of 70, that's opposite over hypotenuse, which is P over 1. So my final answer will just be negative P. Yeah? My final answer will just be negative P. So looking at now 5.2.3. Let me clear everything here. So yeah, is that good, ne? So far so good, guys.
Yeah.
Yeah, let's see. Okay, so here I am. Good. So 5.2.3, they want me to look for the sine of 10 degrees. Ne?
Yeah.
5.2.3, they're looking for the sine of 10 degrees. Oh, I removed that thing, so let me just rewrite it here. So I have 20, 70, then here's my 90, P1 root 1 minus P squared. So for this one, we have sine of 10. But then when you look at our triangle, we have, what's this? 20. Yeah? So basically, 20 is the double of 10, right?
Yeah.
So yeah, it's just like 20 is just double of 10. So what are we going to use? We're just going to use a double angle in a way. Yeah? 3 marks. It's 3 marks now. So what? Another way of writing 10, what can we say? We can say, okay, maybe we can say sine of 30 degrees minus 20 degrees. That gives us 10. Ne? And we know we have sine of 20, we can find it here. And then even 80, that's a special angle. Are we all on the same boat?
Yeah.
Sharp. That's a number one, by the way. Ne? This is a compound angle. So to expand it, we are going to have sine 30 cos 20 minus cos 30 sine 20. Do we see that? Ne?
Yeah.
We all see that.
Yeah.
And then we know what's this? 30 is a special angle, right? Yeah, sorry for the noise, guys. I'm gonna apologize again. Sorry for the noise. So sine 30 now is going to be what? It's a half. Ne? That's a half.
Yeah.
Sine 30. Then cos of 20 we are given here is P. Then minus. Then cos 30, that's what? Root 3 over 2. Ne? That's root 3 over 2. And then sine 20, that's gonna be what? Here we are. That's opposite over hypotenuse. So that's going to be root 1 minus P squared. Yeah? You see that? Then
Yeah.
I just have to work everything out. I'll have what? Half of P minus what? I'm just gonna work this out. Ne? I'm just gonna work this out. So also be careful of the what's this? The square roots, ne? So it's gonna be I know everything here. So this basically I'm just going to multiply my numerator and my numerator, denominator and my denominator. So my denominator will have a 2, right? I will have a 2. And then well, what will it be? So I'm just gonna have root 3 multiplied by root 1 minus p squared. Ne?
Yeah.
Yeah. Then when it's like this, here I can have, let's see. This is multiplication, so I'll have p over 2 minus root 3 root 1 minus p squared over 2. So it's the same denominator, so I can put both of them under one denominator, and I'll have p minus root 3, then root 1 minus p squared. So that's the answer, basically.